So here we go. Today we're going to look at Section 8 and Section 9 of Chapter 6. We're to the point now that we're going to start putting some of these ideas together so that we can solve and graph all of these at one time, but we're going to do one step at a time. Again, everything we've done is leading up to solving and graphing a polynomial given just a generic polynomial. But first we're going to look at special cases. So 6.8, analyzing graphs of polynomial functions, example 1. I have f of x is equal to 1/4 x plus 2 times x minus 1 quantity squared. I want to graph this. Now, first thing I need to remember that this is an x squared and this is an x to the 1. If I FOIL this out, multiply all this out, I'll end up with an x cubed function. So my degree of this is x cubed. My leading coefficient is 1/4. So that tells me that I'm going to have x cubed is odd, leading coefficient is positive, so I'm going to end up with a positive Egyptian type graph. Okay, so I know I'm going to start low in quadrant 3, and I'm going to end up somewhere in quadrant 1 going outside of the quadrant so that I can see that's kind of what my goal is going to be, is something like that. Well, what do I know? Well, I know that I have one root, which is x plus 2, one factor x plus 2, and another factor, which is x minus 1. That first factor x plus 2, if I was to solve that for x, so I would say x plus 2 is equal to 0, subtract 2, x is equal to -2. That's my root. That's my 0. So that gives me the point -2, 0. That's my x-intercept. So I go to the point -2, 0, and I know that's a point that's going to be on my graph. What's my other 0, my other root? Again, I take my factor x minus 1, set it equal to 0, so x is equal to 1. So that's the coordinate 1, 0. That's my other point right here. Now I need to think about this graph and what it's going to look like. Again, I'm going to start low in quadrant 3 and go up to quadrant 1. Well, what else is in my equation that I haven't used yet? What else is that's in my equation that I haven't used yet is this squared that I just erased. I'm going to write it in again. That squared, that tells me that my point 1 is a double root. So that tells me that my graph is going to come down and touch it from the top, or it's going to come and touch it from the bottom, depending on which direction. But since it's a double root, it goes in 2 directions off of that point. So that gives me an idea of what my graph should look like. So I'm going to start low in quadrant 3. I'm going to come up through my first point going one direction. I'm going to have to change directions, come back. Sorry, I had a little sneezing fit. Let's try this again. So I'm going to restart this so that I get my bearings again. I'm going to start in lower quadrant 3. I have to come up through this point here, back down, hit this one, but this is going to be the bottom of a vertex, and then I'm going to go off into quadrant 1. This goes through my 2 zeros with my 2 factors. It goes through -2, 1. It goes through my other factor, 1, 0. I know that 1, 0 is a double root, so it hits it and then comes off. It goes in 2 directions, not just one direction. Don't forget my arrow down there. I know since it's odd and it's a positive leading coefficient and has to be positive Egyptian, and this is what my graph looks like. That's analyzing graphs of polynomial functions without using a calculator. Let's look at another example. Again, looking at this, what do I have? Well, I have an x squared term and an x to the 1 term. So if I go ahead and I was to multiply all this out, I would end up with an x cubed term. My leading coefficient would be this a in front, this -2. So it's an odd degree, negative leading coefficient. So I'm going to end up with negative Egyptian of some sort. Okay. So what are my zeros? Well, my zeros, let's look at them. I can do this in a couple ways. This first one, x squared minus 9. I need to make that into 0, so I could either factor that into x plus 3, x minus 3, equal to 0. So that means x plus 3 is equal to 0, so x is equal to -3. X minus 3 is equal to 0, so x is equal to +3. Let me fix that, -3. So my two zeros then are -3, 0, and 3, 0. The other way that I could do that real quick is I could have said that x squared minus 9 is equal to 0. Add 9 to both sides. X squared is equal to 9. Square root both sides. X is equal to plus or minus 3. Get the same answer. All right. Regardless of how I got it, I have my two zeros, -3, 0, and 3, 0. So I'm going to put that on my graph, -3, 0, and 3, 0. I have another 0, x-intercept or root, x plus 4. Again, you set that up the same way. Over here to the left, x plus 4 is equal to 0, so x is equal to -4. That gives me the point -4, 0. So -4, 0 is right here in red. So I have negative Egyptian. I have my 3 zeros, my 3 x-intercepts. By looking at this, I'm going to start up here in quadrant 2 and then somehow come out here in quadrant 4. So I just need to hit my zeros as I do that. So I'm going to come down in quadrant 2. I'm going to hit this first 0 and quickly have to turn around to hit my second 0. And then I'm going to come back up and then come back through my third 0 just like that. My graph looks like that. That's what it looks like. I have my function here. I have my 3 zeros. From x minus 2, x squared minus 9, I got -3, 0, and 3, 0. From x plus 4, I got -4, 0. Plotted those points, realized it was negative Egyptian, drew my graph. So what are we going to do next? Well, let's grab out our handy-dandy graphing calculator. If you look at this example, before I go on to example 2, it would be really nice and really awesome if I could tell where this point, this minimum of my graph is, and where this maximum of my graph is. That would give me 2 other points, and it would give me a better measurement of what my graph should look like. So our next example is going to use our calculators to go ahead and find not only the roots, the zeros, but those minimums and maximums. So example 2, graph each function, identify the x-intercepts and the points where the local maximums and local minimums occur. The first thing I want to do is I want to pull up my handy-dandy calculator. This is a calculator type problem. We are not going to show you how to find maximums and minimums without a calculator, so use your calculator. F of x equals x cubed minus 3x squared plus 2. So I go to y equals. I plug in my function. My function is x. I go to math to get the cube. Minus 3x quantity squared plus 2. If I graph this, I see all 3 of my zeros. Now I'm going to cheat, and I'm going to pull up a bigger picture and move that over here so that we can see it. So here's my graph. What do I want to find? I want to find 5 things really, but 3 different things. The first thing I want to find are these 1, 2, 3 zeros. I next want to find this maximum, and then I next want to find this minimum. I want to find all those points. I need to identify all 5 of those points. So again, I go back to my calculator. I'm going to bring this back down. You can use either the zeros under second trace. You can use number 2, 0, or we can use number 5, intersect. That's what I like to use. So I'm going to go back to y equals, make y2 a 0, and then I'm going to hit second trace to go to the calc menu. Number 5 is intersect. My first curve is the x cubed. My second cubed is y equals 0. My guess, I'm going to scoot to this one on the left and hit enter, and I get negative 0.732 and 0. So this first point turns out to be, I'm going to do it in blue, negative 0.7320. That's my first 0, my first x-intercept, my first root. I need to find the other 2. So I go back to my handy-dandy little calculator. I hit second trace to go to calc. I hit number 5 for intersection. First curve, second curve are the same, but I'm going to move my guess to this middle point and hit enter. This is the point 1, 0. I'm going to do this one in black so it stands out a little more. This is the point 1, 0. And now I have my last point I need to find. So I'm going to go second trace to go to the calc function, number 5. First curve enter, second curve enter, go over to close to this third point, and I'm going to hit enter. And I get 2.7320. So again in black, 2.732, 0. How many decimal places? 3 seemed easy for this problem. If you normally round to 1 or 2, I'll be good with that. So I have my 3 intercepts, my 3 x-intercepts, my 3 zeros, my 3 roots. I now need to find the maximum. So I'm going to go back to my calculator. I'm going to hit second, go to trace the calc function, and I want number 4, maximum. I want a left bound, so I'm going to hit the left arrow button until I'm left of that maximum. I'm going to hit enter. Right bound, see how it gave me that little arrow right there? It tells me, okay, this is where your left bound is. I'm going to arrow over to the right and hit enter. And so you're telling it, hey, there's a maximum between these 2 arrows. I'm going to put the cursor in the middle someplace and hit enter. Now, I have 2.0538e to the negative 6. What in the world is that? Well, think about that. That's telling me 2.05 times 10 to the negative 6. That means move the decimal to the left 6 times. So that's 0.123452205. In calculator terms, that's the number 0. In calculator terms, that's as close as it's being able to get to 0. So this coordinate is actually 0, 2. So in green, I'm going to say this is the maximum 0, 2. This is my maximum. The next thing I need to find, I'm going to do this in red instead of green again, is my minimum. My minimum is going to be this point down here. I go back to my calculator. I hit second trace to go to the calc menu. Number 3 is my minimum. A left bound. As long as I'm left of that minimum right there, I'm going to be okay. So I'm going to hit enter. See, there's my little arrow. I want a right bound, so I'm going to arrow over to the right of it, hit enter. There's my 2 arrows. Go to the middle, hit enter, and I get to negative 2. Yes, it's 0.0000008, but that's the calculator having round off problems, and so that point is the point 2, negative 2. So using my calculator, I found my 3 intercepts, my maximum and my minimum. So if I was graphing this, it'd be a lot easier for me to plot all those points and have it be a more exact graph. Let's try another example. X to the 4th minus 4x cubed minus x squared plus 12x minus 2. So I'm going to go to my calculator. I'm going to hit y equals I'm going to plug in my function. Starts with an x to the fourth. So I'm going to clear that just not to make a mistake. This is x to the fourth minus 4x to the third minus 2x squared plus 12x minus 2. X to the fourth minus 4x cubed minus 2x squared plus 12x minus 2. That's wrong. There should be no 2 here. So if I move it down here and check again, x to the fourth minus 4x cubed minus x squared plus 12x minus 2. Those are the simplest little mistakes that are going to kill you every time. You have to make sure you do it right. Let's go ahead and graph it. I'm using a standard graph, negative 10 to 10, negative 10 to 10. I can see all my points, which is good. I'm going to go ahead and make the big window so I can kind of work my way through this. And so I have several points. In blue, I'm going to have 1, 2, 3, 4 intersection points. In green, I'm going to have 1 maximum. And in red, I'm going to have 2 minimums. Now I'm going to use the calculator and do this kind of quickly, so let's see how this works. So again, I want to go to first go to y equals, and remember that my y2 is 0, so I can use intersection. Second trace, go to the calc function, number 5 is intersection. 1, 2, go over to this point over here, and I get the intersection negative 1.60. So this first one is negative 1.60. Go back to my calculator. Second trace to go to calc. Number 5 is intersection. First curve, second curve. Arrow over to this point. It looks to me like it's 0, 0. And it's 0.170. Oh, so close, but yet that's still a different number. So this is 0.170. My third 0, or x-intercept or root. Second trace to go to calc, number 5 is intersection. I want first curve enter, second curve enter, go over to this point over here. Hit enter. 2.250. And lastly, my last 0, number 5, intersection, enter, enter, go over to the last one, hit enter, 3.20. Those are my 4 intercepts. I need to find my maximum and my minimum. So I'm going to move on, and I'm going to hit second trace. Number 4 is maximum. Left bound, I'm going to go to the left of that maximum, hit enter. Go to the right of that maximum, hit enter. Go to the middle, hit enter. 1.14 and 6.14. See why we're not doing this by hand? We let the calculator do the heavy lifting. And so then I'm going to go second trace. I want number 3 for minimum. Left bound, I'm going to go to the left of this one. Hit enter. Right bound, go to the right of it. Hit enter. Go to the middle. Hit enter. Negative 0.94 and negative 10. And my last one, and I'm trying to save time on this, second trace. Number 3 is minimum. Left bound. I have to get as close to this point as I can, at least within that little hump. There's the other one. Go to the middle. 2.79 and negative 2.58. I believe this was a positive 2.79. Okay, so there's the points that I need. Let's move on. We're at 20 minutes. I need to do one other thing. Modeling with polynomial functions, example 1. Write the cubic function of the graph. We're just going to have one example from section 9. I want to write a function of this. Factored form is fine. What do I know? Well, I have 1, 2, 3 roots. If I'm looking for a cubic, I should have 3 roots. I then have a fourth point down here. I'm going to use these to write my function. First, I need to remember in factored form, my function is going to be some number a times x minus some number times x minus another number times x minus another number. In factored form, that's what it looks like. I need to find what those 3 numbers are. Those 3 numbers, if you remember, are my zeros, my roots, my x-intercepts. And I have my 3, I don't want to cross it out. I have 3 x-intercepts, 1, 2, and 3. So I'm going to plug those in. X minus a negative 3, x minus 2, and x minus 5. Those are my intercepts. I've got them. What am I missing? I'm missing my letter A. Well, how do I find A? Remember, I had this other point right here, this 0, negative 15. I'm going to plug that in for my f of x and for my x. So I'm going to get negative 15, which is my y term, is equal to A times 0 plus 3, because x is 0, 0 minus 2, because x is 0, 0 minus 5, because x is 0. I love my A's. They start turning into 9s. That's my A. So what does this get? Negative 15 is equal to A times 0 plus 3 is 3. Negative 2, 0 minus 2 is negative 2. 0 minus 5 is negative 5. So negative 15 is equal to A. 3 times negative 2 is negative 6. Negative 6 times negative 5 is 30. So A is equal to positive 30. Divide both sides by 30. I get A to be negative 15 over 30, or negative 1/2. So my final function, my final answer, I'm going to write it right above here, is f of x is equal to negative 1/2 x plus 3, x minus 2, x minus 5. All I did was I took my zeros, plugged them in into the 3 factors. Since I know it's a cubic, I can plug that in. I have to find A by using my fourth point. Those are all the notes. Have a good day. I'll see you tomorrow.